जी सर.
Now come to the another question. It is exactly similar to the previous question with the very small changes. And here, first part, if y equals to 1 by cosine of theta, then you have to prove that dy by theta is equal to secant theta into tangent theta. The solution of the first part is very simple, and you can use the u by v formula. The u by v formula for the derivative. So the derivative will be equals to y prime, mean the derivative with respect to theta. I'm using the u by v formula for sine of theta is written here. And taking the cosine of theta as it is, and the derivative of the numerator 1 is derivative is 0, minus taking this one as it is, that the derivative of cosine is the negative sign. And of course, after simplification, you can write this. It is actually sine theta in the numerator, and it can be written as cosine of theta into cosine. So I can write this is 1 because it's because it is possible. It becomes 0 minus into minus plus sine theta is here. So what is this? It is actually the tangent of theta. And of course, it is equal to secant of theta. Therefore, we get this. The answer of the first part, the derivative of 1 by cos is this. It is actually the repetition. Now you have to prove the second part of this question. What is the second part? Prove that this is equal to this. Here you have 1 plus sine and divided by 1 minus sine. I took the left hand side and I want to prove it is equals to this actually. So how can I do this? ऐसा कैसे होगा? So this is the one of the ways to multiply it with 1 plus 1 minus 1 plus sine of theta and 1 plus sine of. And then what is this? Actually, if you multiply these two, it becomes 1 plus sine square. The sine of whole square. And the whole divided
सर
by.
हम इसमें 1 + sin थीटा क्यों मल्टीप्लाई करें, और मतलब हमें कैसे पता चलेगा कि हमने ये करना है और 1 - sin थीटा नहीं करना?
It's a good question.
इसको कॉन्जुगेटिव कहते हैं ना, ये जो आपने साइड पे किया
No,
मल्टीप्लाई.
it's not conjugate. So rationalization भी लोग आप कहते हैं इसको जो है ना, इसका रियल कॉन्जुगेट तो नहीं, खैर यहाँ कह सकते, वो तो इरेशनल नंबर्स में होता है. But after a lot of practice, when you practice the trigonometry, I think the idea automatically come into your mind. Here, I think when I want to simplify this, I don't see any other way to simplify this. I think if I multiply it by 1 plus sine and 1 minus sine, at least this become 1 minus sine into 1 plus sine become 1 minus sine square theta. So it will become one term. And then we maybe it's possible to get another way to get this your answer. So at least this give you the one way how to prove this. It's our trial, not the exact method. Exactly, you cannot memorize the things, but after practice, you will get some ideas about this. And in the next step, it's obviously we shall open this plus 2 sine of theta and plus sine of square theta. And of course, what is this? It is equals to cosine of square of theta. Now, what is our option? This is option, we can take this cos in the numerator. I mean, 1 by cos can be written as secant square. It can be written as secant square into this whole expression, 1 plus 2 sine of theta. So that I get the secant square with it. It is my success. I created secant square because secant square is here. So I wanted to get secant square in any way. I get this. Now, on furthermore, if you multiply the secant inside the bracket, open the bracket. If I open the bracket, what I will get? After opening this bracket, I will get secant square. It is involved in your solution. Then multiply this by secant square. It is actually 2 secant square into sine of theta. And then multiply the secant square with the sine square plus secant of square into sine. Now, further, I have to think there is a term involving tangent and there is a term involving only one. What I have to do there? अब मुझे क्या करना चाहिए? What to do here? Because it becomes secant, it is, and of course it is actually required to tangent to secant into tangent. If I write this secant into secant, then write 1 secant in the numerator like this. Look here. If I write the secant as it is, and plus 2 secant of theta into secant of theta, and secant theta can be written as 1 by cos theta. I break the secant square and write the secant into 1 by cos, because 1 by cos once again secant, and this is sine, or plus. It is actually secant square of theta, but we don't need this term sine square. Here, because in answer there is no sine square, so I can change this into the cos square. I don't like this sign here, so that's why I change this sign into the cosine. So what is this now? It is secant square of theta plus, what is this? 2 secant of theta. What is this? Sine by cos. Sine by cos is tangent theta. And what is this? Multiply this secant in with the 1. Open the bracket. Secant square of theta. And minus secant square multiplied by the cos square. We get this result. And now what is this? What I can do? I can multiply the secant with secant. So I get the secant 2 secant square. I get this. Then I already get this 2 secant of theta, okay, into tangent theta. Then minus, this is actually the reciprocal of cosine. Actually it is 1 by cosine. So this is cancelled with it. So it becomes 1. I get this proof. It is proved. Look here. If you have any question, you can say the question. The first step was to take the left hand side, multiply and divide with 1 plus sine, and then multiply the numerator. I get this square, then multiply this, open this, we get this, and write the sine times 1 plus sine. It becomes 1 minus sine, and 1 minus sine can be changed into cosine of square. Then take the cosine in the numerator, then multiply inside the bracket with every term. And then we multiply, we get this secant here, and break the secant, it write the secant into secant, and then 1 secant it become 1 by cos into sine, and plus secant square into, I change this sign into the cosine square. So the multiply inside the brackets, I get secant, and then multiply the secant with the cosine, if they will be cancelled. So eventually by adding the both secants, this secant and this secant, I get the 2 secant. And similarly, this write this term as it is, and this becomes 1. So we get the proof of the first part. Now I think everything is clear in the 2 parts. Now we go to the third part of this question, actually, which is the integration. Now come to this integration. So far as the integration is concerned, I taught you in the previous lesson, if there is no direct formula of integration of a trigonometric functions, then you have to think about the trigonometric identities and change your given question in the form of the basic 4 formula of trigonometry. And so we'll do here. And the examiner already said you change this into this form, and we write using the second part, we can write this as the integration of pi by 4 and write this whole term 2 secant of square theta plus 2 secant into the tangent and minus 1, here is this theta. Now what to do? You know its integration is tangent. Write the 2 tangent of it, because it is the basic formula of integration. And you know secant x into tangent x is actually the derivative of 1 by cos, or you can say its integration is 1 by cos. So I can write the integration of this 1 by cos, or 1 by cos, or you can write it as a secant, and minus the integration of 1 is theta. Write the limits 0 to pi by 2. And in order to put the limit, first of all, I put the limit pi by 4, and you must know the tangent of pi by 4 always equals to 1. Secant of pi by 4, it is always equals to square root of 2, as in we explained in the previous lesson. And also at 0 degrees, you can know the values. Tangent of 0 is equal to 0 and secant of 0 is equal to 1. So putting the upper limit, we get twice of 1, because tangent of pi by 4 is 1, plus twice of secant theta pi by 4 is square root of 2 minus pi by 4. And then put 0. If I put 0, tangent of 0, as you can see, it is 0, plus twice of secant of 0 is 1 minus 0. Now simplify. It becomes 2 plus 2 under root of 2 minus pi by 4 and minus 2. The first 2 and the last 2 can be cancelled. And finally, we get the exact form of the answer. The previous question and this question are alike. This is the final answer. Once again, I'm repeating all the steps. First of all, we have to use the second part to do this, and this integration is tangent. Integration of this is secant theta, integration of this is. Then you must know the values of these trigonometric functions. And if you know the values of these three trigonometric functions, then you can evaluate the upper limit here and write all the values. Then the lower limit put over here to get all these values. Then simplify and get your final answer. This is okay. I think everything is clear from all the parts of this question. This is the criteria how you can study the trigonometric functions integration. practice a question again and again, again and again. So you will get new ideas how to prove your question.